Alright, in this video here we're going to do some word problems that involve linear functions. Right, and word problems in which we actually have to write the linear function ourselves and then use that function to solve a problem. Right, so the first problem here, Paul opens a savings account with $350. He deposits $150 per month with no withdrawals. Alright, so if you have, before we get into doing this problem here, if you haven't watched the other videos that I did about linear functions and the form of a linear function and things about the slope and the rate of change, you might want to look at some of those other videos because here I'm not going to really explain a lot of that stuff, just kind of go into solving the problem. So for this problem here, the first thing we have to do is find a linear model for this particular situation. Right, so if you recall from the other videos that I've done, for a linear model, there's really two numbers that we're concerned with. It's the slope of the line and then the y-intercept of the line. Right, so if they give us two numbers in the problem, which they do here, the 350 and the 150, probably one of those is going to be the slope and the other one's going to be the y-intercept. We just have to be careful to make sure we pick the right one for the right spot. All right, so let's see. He opens his saving account with $350 and then he deposits $150 per month without any withdrawal. So he starts with $350. Right? This is my initial amount. That's going to be my y-intercept. Right? Because that's what he's starting with. At time zero, he puts $350 into this account, and then he puts in an additional $150 per month. Right? This $150 here per month, that's going to be our slope or our rate of change. Right? Remember, the slope of the line is the rate of change of the situation that you're talking about. Right? And the clue words, a lot of times the problems will use the word rate in there. This one doesn't have the word rate, so how do I know that that's the rate of change? One clue is this other word here, per. It's dollars per month. Right? So if it's dollars per month, it's the rate of change, it's the rate that the dollars are changing as the months go by. Right? That's a rate of change. Therefore, that's going to be the slope of my line. All right? So I can write my function or my linear model as y equals 150x plus 350. All right, and that 150, I don't know why I can't write those numbers correctly here. So y equals 150x plus 350, where x equals months, right, the number of months since he opened up his account, and my y is dollars, the number of dollars that he has in his savings account at that time. Right, so when you're writing a linear model, there's really two things to it. It's the equation itself, but it's also telling what those variables represent. Right? If you just give somebody this equation, y equals 150x plus 350, but you don't tell them that x is the number of months and the y is the number of dollars in Paul's savings account, then they don't know what to do with this equation. Right? So you need to have both of those things. The equation that relates to variables, but then also a little thing that indicates what those variables mean for this problem. All right, and again, to decide which number is which, the slope, right, the number that's attached to the x, that's your rate of change, right? So in this case, the dollars are changing per month. There's my rate of change. The y-intercept is your initial amount, what you start with. He's starting his account with $350. That's my y-intercept. All right, once we get our model, the question now is how long until he has $2,000 in his account? All right, well, once I have the model, now I just have to use that to solve this problem. All right, so $2,000. Do I plug that in for x or do I plug that in for y? Right? It's one or the other. I got to decide which one. Well, and this is why it's important to label what your variables mean. X is the months, y is the dollars. $2,000, well, that's dollars, right? It's pretty obvious there. $2,000 is not months, that's dollars. Therefore, that $2,000 has to go for the y. Right? The biggest mistake people make in a problem like this is just saying, oh, well, here's my equation, here's a number, let me plug the number in for x and just do the calculation and I got my answer. Sometimes that's what you do. Like if the question said, well, how much money will he have after 5 months? Well, 5 months is an x value, I would plug that 5 in for the x. But if they give us dollars, that's y. Read it carefully, know what the variables represent, make sure you put the number in the right spot. Right, so 2,000 equals 150x plus 350. All right, and now, in order to figure out how long it's going to take him to reach $2,000, I solve the equation for x. All right, so the first thing is I subtract the 350 to the other side. So that's going to give me 1650 equals 150x. And then I divide both sides by 150. And 1650 divided by 150 would be 11, I think. So x equals 11 months. I believe that equals 11, although I do have a calculator here, so let me just real quick check that out. 1650 divided by 150, yes, is 11. Good. Okay, so it's going to take him 11 months until he reaches $2,000. And remember, the answer to this is not just 11, it's 11 months. It's a length of time, so put the units on your answers. I know a lot of teachers harp on that. You have to label your answers. It's important because when you are communicating the mathematics that you do with other people, you have to tell them what you're doing and, saying, oh, it's, he's going to have $2,000 in 11. Like, you wouldn't say a sentence like that. You would have to say 11 something, 11 years, 11 months, 11 days. You wouldn't just walk in and say, oh, I'm going to have $2,000 in 11. What are you talking about, right? So put the answer there, or put the units on there, 11 months. All right, so that's our first example of, given a word problem, writing a linear function, and then using that function to actually go ahead and solve a problem. I'm going to pause the recording here and erase this example, and we'll put up one more where we'll do something pretty similar. But it's going to be a little different. All right, so in this example, we have Joe on a diet. He weighs 260 pounds, and he loses 4 pounds per month. We want to, once again, just like that last example, write a linear model, and then use that model to answer a question, how long does it take until he reaches 220 pounds? All right, so similar to that last one that we did, but there's one thing here that's a little bit different. All right, so if I want to write my linear model, once again, I need two numbers. I need my slope, or my rate of change, and I need my y-intercept, or my initial amount. All right, so what's his initial amount here? Well, right now he weighs 260 pounds, right? That's my initial amount, so that's going to be my y-intercept. And then his rate of change, well, he loses 4 pounds per month. All right, so this 4 is going to be my slope, which is my rate of change, right? Remember, the key thing for a linear function, the slope and the rate of change are the same thing. So again, identifying the slope, he loses, right? That loses indicates that something is changing. And then the other thing is we have the pounds per month, right? It's 1 unit per something else, per time, right? So it's pounds per month. Anytime you see that word per, generally that's going to be your rate of change, right? That's one of those keywords that you can look for to know that you have a rate of change. All right, so again, the y-intercept is your starting point, your initial amount. In this case, he starts out weighing 260 pounds. And then the slope is your rate of change. How is that his number of pounds changing over time? Well, he's losing 4 pounds per month. All right, so if I write my function here, my linear model, y is equal to the slope, 4x, and then plus his initial amount, 260. Not quite, right? I made a mistake there. I did it intentionally. Hopefully you noticed what that mistake is. But there's something a little bit different in this problem than the last problem, right? If I write it like this, right now he weighs 260 pounds, and if my slope is 4, that means that his weight would be increasing by 4 pounds each month, right? But he's actually losing 4 pounds per month. His weight is decreasing, which means it has to have a negative slope, right? So it should be y equals negative 4x plus 260. Right, so when you're doing these word problems that involve linear functions, that's one of the little tricky things about it. You have to read the question carefully and think about, once you find what number is the y-intercept and what number is the slope, then the question is, well, is the slope going to be positive or negative? Is it increasing or is it decreasing? Right, the word loses here indicates that it's going down, and so I'm going to have a negative slope or a negative rate of change. Right, so look for those key words, his weight, he loses these pounds, his weight plummets, his weight drops. That all indicates a negative rate of change, a negative slope. Or if it says he gains 4 pounds, that means it's a positive slope, it's going up, right? Or it increases or something like that. Those are words that tell you that the slope is going to be positive, right? So you do have to read these problems carefully. Sometimes the rate of change is positive, sometimes it's negative. It all depends on whether it's going up or down. In this case, it's going down. His weight is going down, and so we have a negative slope. All right, and here my x represents months since he started his diet, right? And I know that because it's 4 pounds per month, right? Whatever time unit they give me there, that's going to be my units for the x. And then the y represents the number of pounds that this guy, Joe, weighs. All right, so y is the pounds. X is months, y is pounds. Again, just like that last example, write the equation, but then also tell what those variables represent. That makes it easier to do part B here, which asks us how long to reach 220 pounds. All right, well, 220 pounds, that's a number of pounds, so that 220 goes in for the y. All right, so I go back to my equation. 220 for y equals negative 4x plus 260. All right, and then I solve that equation for x. So pretty basic here. If you remember how to solve linear equations, I subtract the 260, so that's going to be negative 40 equals negative 4x. And then when I divide both sides by negative 4, I get that x is equal to 10 months. All right, again, just like with that last example, the answer is not just 10, it's 10 months. All right, and just like I said for that last one, like you wouldn't walk in and say, oh, I'm on a diet, I'm going to be down to 220 pounds in 10 minutes, in 10 years, 10 what, right? So give the answer as 10 months, okay? So that's doing a couple linear function word problems. Again, identifying the initial amount, the starting point, that's your y-intercept, that's your constant number. Identifying your rate of change, right? How is it changing over time? That's your slope, the number that's attached to the x. And then also paying attention to, is it increasing or decreasing? Is that slope positive or negative? And then once you have your model written, you can go ahead and use it to solve all types of different problems. How long will he reach 220 pounds? What will he weigh in 3 months? Plug in x equals 3 to solve that. You can answer all types of different questions once you have that model written. All right.